For the introduction. Thank you, sir. So, hello everyone. Welcome to our first uh, uh, medical AI and imaging. That is the topic workshop. So this is gonna be the first of the three workshops. So I'm gonna see you guys if you would like to join me next week the same time. It's gonna be the second one and then the third one. So we're planning to have three series of this workshop, as Dr. Bade mentioned. I'm gonna have a deeper and then more extended version of this workshop I'm planning to have an 8 week long study on medical imaging. So for today's workshop, I uploaded the material here. So I'm now sending the message. So you can download the material from this GitHub account. I just uploaded the material, and let's see if you have any problem. If you do, then I'll give you another address. So that's the first thing. Second, I have been working on projects involving medical images for a while. Once I read the image and then begin to work on the image, doing transformations, training models, I really forget the basics of how actually I handle the image. So this workshop will also be a very refreshing what is that reminder for myself, actually, how I deal with images. I'm gonna assume that we are all new into this domain. Uh, and if you guys already have VS Code or uh, Anaconda installed in your computer, you can open your Jupyter Lab, Jupyter Notebook. If you don't have any of that, you can open your Google Colab, and then you can start working with me. This time, because it takes time to type the code, this time I shared the file that I already have all the code typed. We are just going to work on each cell one by one together. The workshop is going to take around 1 hour, so I'm going to end after like 55 minutes. Right. So thank you. And then let's get started. I'm going to share my screen. Just 1 second. So this is my screen. So this is where I suppose you're going to get your material. So I shared it. This is the first module, the first file, and these are the images. Some of the images I will use in the next meetup too. So these are the images we're going to use in this session. I lost the. um, let's see, just 1 second to take this to the other side. Bring my screen. Okay. I hope you guys are now seeing my screen. If you have any questions, any comments, please post your questions on Q&A. If you post your questions on chat window, I may miss the questions because on the chat window we are posting links to our other programs. If you are following us, we just finished our first AI healthcare conference at Stanford, actually. This Thursday and Friday, it was actually a huge success. And then I think it's meaningful we just start working on medical image processing now after the conference. So here is again the files, and then I'm going to open the file. So this is the file that I will be working on. So this one. Okay. And then this will be the folder. I will have all the images inside. So let me get rid of this one. And then if you guys are ready, yes, Ms. Oymax, I'm going to actually, I just uploaded everything just before the workshop. I didn't have any time to actually write for README. So yeah, I will also write README an explanation on what is the plan for the next meeting. That would be, yeah, I agree. That would be helpful for everyone to follow up what's happening. Okay, so let's get started. I also included some links to other materials, which I find very, very useful. I also use some of these materials. I compiled them. So I strongly recommend going through this material. Actually, it is a very abundant amount of resource available on these links. So yeah, Anjali. So I just shared the link to the GitHub account. Here it is. I will also put on the screen so you can type it in case anyone joins later. So this is the GitHub account that has the material for today's lecture. into the material for today's workshop. All right. So first of all, we are going to start from what is image made of? What is an image made of? Image is actually made of numbers. When you are building a machine learning model, right? So the input to your model is numbers. If your variable is categorical variable like yes, no, like red, blue, right? So you turn those categorical variables into values like 1, 0, 1, 2, 3. Similarly, when you have an image, you need to turn those images into numbers so that you can work on them. Any image is actually made of numbers. So these numbers are stored in terms of lists, like matrices and arrays. We call them arrays. So I'm gonna here, first of all, we are using NumPy as a library to deal with matrices and vectors. And I'm going to use imshov. Let me make this a little bigger. imshov so from matplotlib's pyplot to plot any of the figures. So later we're going to use some other libraries as well. For now, we have these two. So the first thing you see is a list. This is a list of lists. So in this list, I have, let's say, the first list inside this. This is a list of lists. The first list is actually the first row of a matrix. So this is a matrix, and this very first highlighted list is the first row of that matrix. And then I have the second row. As I add more rows, each row, right, so is increasing the dimension of the matrix. And also each row has a number of elements, and each element is actually corresponding to a column in my matrix. So as of now, when I run this, I'm gonna see this is the list of lists I have. So you can also check what is the length of this list. What is the length of this raw image array? Right now, I cannot use shape because it is not an array. It is a list of lists. Sometimes your images can be given as lists. So I didn't run this. Not array, right? Okay, so I have 7 lists, 7 such lists. And then if you are curious about what is the length of the one of those lists, so again, I'm going to repeat this. I'm just going to copy this. Okay, and then from this list, I'm going to pick, let's say, the first one. So this row image array 0 is corresponding to this very first row, this one. Okay, so let's see. So as you see, I have 7 rows, and this 7, the second 7 is corresponding to number of elements at each list. So I have a 7 by 7 matrix. So if I want to check let's say this third element in the first row, again, let me not repeat typing it. So here is my matrix. So this is the very first row. And from this very first row, I'm going to pick the third element. Right? So 2 is the third element. This one, this 2 here is the third element. Anyway, so this is basically basic Python lists, how we can form list of lists. Now, I'm going to take this list of lists, and then I'm going to turn it into an image. An image is expecting a matrix from us. What it's going to do is it's going to take each of these values, and it's going to it's going to map these values to a certain color with some certain intensity. So that the intensity of the color is a function of how big or small this number is. As you see, these numbers are all integers, means they're 0, 1, 2, 3, 4, right? So what if they are not integers? What if they are decimal numbers? So that is also possible. We are going to see in a minute. Okay, so it just turned into this list of lists into an image. Now, most of the time, we are going to avoid working on images as list of lists. Rather, we're going to work on images after we turn them into arrays, or we're going to turn arrays into images. So what I'm going to do is I'm going to take this list of lists, which I just created here. I'm going to turn it into a NumPy array. Okay. Now my image is an array. So let's see. Now I can get the shape of my image, right? So now I can use this shape attribute, right? So it is 7 by 7. My array is 7 by 7. So you can say image, what is that? D type. So all the numbers in my array are actually integers, right? Int 64, it is 64. Each number is represented by 64 bits. And then and my image is, I sometimes go back and forth between different types of arrays. So that's why I type D type and then sometimes type. So my image is a NumPy array. Okay, right now, what I have is a NumPy array, and each number in this array is of integer 64 type. We're gonna work on more on this. And then the size of this image, this array is 7 by 7. Now, I can subtract, add, divide all the numbers inside this array without actually spending too much time, right? So what I can do is, here is my image. This is my original image. So what I can do is I can divide everything by 6, right? So now my image, the values inside this array are turned into some numbers between, in this case, I don't see anything from bigger than 1, between 1. So I can also do this. This works. So I can take the maximum of the numbers. So my image has 7 by 7, 49 numbers. I take the maximum of these numbers and divide every number inside my array by that maximum number. So why am I doing this? This is an important step when we start working on our images. What I just did is I normalized my image. So all the numbers in my image are now between 0 and 1. Okay, so there is some reason why I am dividing my image by NP max of all the numbers in my image. So as of now, I can, as you see, I can work on each and every element in my image. I can broadcast an operation, right? So I can divide, I can subtract, I can add, I can multiply, and that's going to be important later on. All right, so let's continue. As I said, I can get the shape of my image, and then I can get the data type of my image. What I can do is I can change the data type of my image. So what does that mean? So why am I doing this? So let's see. This is my image. Right? So as of now, as you see, all the elements in this array are integers. What if I want to turn them into a float number? Float number is a decimal. All I have to do is take this image, and then I'm going to add this function. As of now, image is a NumPy array. I'm going to type this. Image is a NumPy array. Why is this important? Because NumPy array comes with its own functions, its own methods. One of these methods is as type. So what does as type do? As type changes the type of these numbers. As of now, they're integers. I want to turn them into a float, a decimal number. So again, at this step, all I did is I changed the data type of this 1 into a decimal, a float number, 1.0. Okay, that's all I did. I did not turn my the integers in my array into float numbers which are between 0 and 1. I did not do that. So this is very important. Sometimes without seeing what's happening inside the image, when we type image.astype float, we are thinking that we are changing the array into a float numbers, into an array of float numbers, and those float numbers are between 0 and 1. In other words, we are thinking that when we change the type of array into float using S type, we are also scaling the image. That's not happening. Okay, so S type only does one thing. What it does is it changes the type of the number here. It's as of now, it's integer. It's turned into a decimal number. That's all. It's not scaling. It's not dividing by, say, maximum of, in this case, maximum of 6. It's not dividing these numbers by 6. It's not doing it. It's just changing the type. Anyways, okay. Now I have this image. By the way, I can use imshow, right? So here, remember we imported imshow, so I can use imshow. Uh, my image. So it still works. As you see, image is a NumPy array, and I'm using imshow from Python from pyplot to turn my numbers into an image. Yeah, Kishore, you can post your questions on Q&A. By the way, I forgot to check if there are any questions. So you can post your questions on Q&A if you have any questions. Okay, so that I can keep track of questions if there. We just started, by the way. Okay, you're welcome. Again, for those who just arrived, so this is the link to the material. So this is the link to material. I'm gonna post it one more time. From chat, I'm posting. Again, I'm not making any assumptions on how much we know. I'm assuming as you, like myself, we are just starting to learn this. So what I'm gonna do is, now can I create an array from scratch? Earlier, what I did is I just created a list of numbers, and then I turned this list of lists into an array. Now what I want to do is I want to create an array. That array is going to, you will receive an email later on with the link to the YouTube, YouTube posting of this workshop. I'm gonna create an array with zeros, and then I'm going to assign values to specific parts of the image. Okay, so let's see what's happening here. First of all, this is the size of my image. As you see, this is a tuple, right? My Python tuple, lists and tuples. So my image is going to be 6 by 5. There are 6 rows and 5 columns. And then what I do is, using this image size, which is 6 by 5, I'm creating a NumPy zeros array. So this NumPy zeros is actually creating, let me run this. It's creating an empty array with a size of 6 by 5. So there are 30 zeros. There are 6 rows and 5 columns. So, and then if you want to see what this image looks like, it's, as you see, the dark purple. Basically, we are using a color map. In this color map, 0 value is corresponding to this color. You can change this. You can change your color map. You can say 0 corresponds to black, 0 corresponds to white, 0 corresponds to red. You can change that. As of now, by default, imshow is using this color corresponding to 0. That's why you see all the whole picture is like dark purple. So I'm going to assign 1. I'm going to assign 1. And I know that 1 is, in this case, mapped to color yellow, right? I'm going to assign 1 to a specific position on this image and then see what is the impact of changing the value. So I will assign this the first row and the fourth column. So the first row, fourth column, 0, 1, 2, 3. This one, I will turn this one into 1. So let me. So, as you see, I turned that value from 0 to 1. And then I'm going to print my image one more time. Now, as you see, that pixel, now the image is formed of pixels. Each pixel has a corresponding value. That value is mapped to a color, and that color is printed on the corresponding pixel. That's all that's happening, right? So what I just did is, so in the first row of this image, there are 5 pixels. And then I turned the fourth pixel in the first row. The value corresponding to that pixel is turned into 1, and 1 is mapped by default by imshow to yellow color. So that's why I see that pixel is turned into yellow. That's what's happening. Okay. Now, another thing, I'm just experimenting. I'm going to create this time an array 6 by 5, but this array is going to be a random array. Okay, so let's see. Again, remember, I already imported NumPy at the beginning. From NumPy, I'm going to use a library called random. It's a very useful library if you are using, if you are working on machine learning models. So or statistics, you may need to generate random numbers from, not time to time, actually, frequently. So one of the libraries we use is random. So from NumPy, NP is the abbreviation of NumPy. This, what is it? The library is called random. And from this library, I'm going to generate some random numbers. And these numbers I'm gonna have and the numbers of 6 by 5 matrix. Okay, random numbers, a matrix of random numbers with the size of 6 by 5. So let's see. As you see, these numbers are between 0 and 1. And I have 30 numbers. So this is an array. Now I'm gonna turn this array into a picture. Now, again, look, each picture, each pixel, again, these squares, actually, imagine they are pixels in your image. And each pixel is colored with colored with respect to the value corresponding to that pixel. But this time the values are not integers like we had earlier, right? So the values are now decimal. So don't be surprised. And most of the time, that's what we're going to do. Our images are going to have all decimal numbers, okay? And these decimal numbers in a range correspond to certain colors. And those colors, you can also adjust them. You can change which color is corresponding, which number is corresponding to what color. But here you see those random numbers are actually coloring each pixel with some color. And then I really don't know what is the mapping happening between these numbers and the colors. All right. Now we are going to add a new library to our list. So far we talked about NumPy and the PyPlot. PyPlot, we use it for plotting figures, and NumPy for manipulating arrays and matrices and vectors, basically. I'm going to introduce multiple libraries, by the way. First, let's use skimage as an open source library, sklearns library. skimage is one library that we frequently use. I don't use myself too much, but there is no harm learning a new library. So I'm going to use skimage. If skimage is not already installed, you can install skimage using pip install scikit-image. Okay, you can use this. I'm going to share this on the. If you do not have scikit-image already installed. So from skimage, I'm gonna import IO. As I imported imshow from PyPlot, I'm importing IO. IO is for input output, for reading and writing images, reading from and writing to images. Okay, and now I'm gonna start using, so I'm gonna read an image, okay? Rather than creating the array myself, I'm gonna read an image. And let's see when I read an image, what happens. So I'm going to read an image. To read an image, I'm going to use this method called imread, image read, imread. And that is the path to my image. So my image is called rgby.jpg. JPEG is the extension for that image file. And this is the folder where my image is contained. Okay. Now let's read this image. Okay. Let's read this image. And then let's see what we have now. So what I do is I first read the image, and whatever I read, I assign it to this variable called img. That's what I call it. We can call it anything. Now, when I check the shape of this img, first of all, I'm just curious, what is img? So what is the D type of img? Okay. And D type is not fine type imp. So img, it's a NumPy array. So that's good to know. So what happened here is the image that we read, and what is that image, by the way? So here is M1 images, and this is the image I read, RGBY JPEG. So this is the image that I read, okay? So I read this image, and this image, let's go back to when I read it, it is automatically turned into a NumPy array. We know what NumPy array is. We just discussed. Now, this will not happen automatically for some other libraries. Okay, so we need to know when we read an image, in what format that image is actually read, okay, into the platform now. So we read the image, it is already a NumPy array. So that means I can use the attributes of a NumPy array on this image, which is img. As of now, this is not image anymore. It's a NumPy array. So what I can do is I can check its shape. Now earlier, our image was 7 by 7, 6 by 5. It had 2 dimensions, right? So right now I see there are 3 dimensions. I know the first the first one is number of rows. The second one is number of columns. How about this third one? So why do I have this third dimension, right? So this third dimension, and then its value happens to be 3. So it doesn't have to be 3. It can be 1, it can be 2, it can be 3, it can be 4. So what does it mean? What is this 3 here? So as of now, what this tells me is this IMG array, it is a NumPy array, a matrix, but it is not a single matrix. So there are actually 3 matrices. Okay, there are 3 matrices which are actually stacked together. Okay, matrix 1, matrix 2, matrix 3, and each matrix has a size of 586, 415. Imagine that there is one matrix, 586, 415. There is another one. There is another one. You just put them back to back. Okay, you just put them like 3 papers, okay, on top of each other, and then this is our image. In other words, our image has 3 channels. So this number 3 here is corresponding to channels, number of channels. What is channel corresponding to here? Channel tells me if my image, in this case, is a black and white image or it's a colored image. So if it's a black and white image, it's just it's actually I can only map the numbers in my array to a shade of a single color. Okay, so this can be a red, this can be a green, this can be blue. If there are 3 channels, each pixel I see on my image, each pixel will be a combination of 3 colors, which are in this case a red, green, and blue. So by combining red, green, and blue, I'm gonna have too many different levels of too many colors. Okay, I'm gonna have too many different colors. Okay, so then each of these matrices, what are they corresponding to, right? So earlier we said this number is corresponding to a certain color in my color map. So when I see this number is turned into a color in my color map, and that color is printed on this pixel here, on this small square here. So when I have 3 numbers, so when I have one matrix, a second matrix, a third matrix, so from these 3 matrices, I'm gonna pick the number in the same location in these three matrices. Let's say from each matrix, I pick the number at the top left, which is say 0.36. This is the first matrix. The second matrix can be 0.1. The third matrix can have a value of 0.5. Again, all these 3 numbers are corresponding to same position, top left. So this time, the first matrix, it's going to, from the color map, it's going to the color for red, whichever, so it is RGB channel. So this number 0.36 corresponds to a shade of red on the color map, okay? So the second matrix corresponding to the same position, that number will pick this time green, okay, from the color map, and then the other one will pick blue. And we're gonna combine these 3 together. Like take the colors and then on your palette, you just mix them up. And that color, the resulting color, is going to be printed on this pixel. So that's what a 3 the color, I'm sorry, 3 channel image is going to be looking on my screen. So let's continue. What I'm gonna do now is I'm going to, see, I just printed the shape of my array. I checked the type of my array. It's a NumPy array. And now I am going to do some work on this array. So what am I doing? Remember at the beginning, I told you, by the way, let's see how this, I'm just going to, let's say, print on the screen the number on the top left, okay? So how can I do that? So if I say 0, so what does that mean? If I say 0, what does that mean? So 0, 0. So let's see what does this mean? What is this 096? What is this number 096? So these 3 numbers are corresponding to the top left for 3 channels. So this is coming from the first matrix. This is coming from the second matrix. This is coming from the third matrix. And these numbers are positioned at top left. So if I say 0, 0, 0, I'm printing number 0 here. If I say this is coming from the first matrix, if I say 0, 0, 1, this is the first matrix top left, okay, which is 9. If I say 0, 0, 2, this is again, the third matrix top left. So if I say this, again, I'll get the same thing, 0, 9, 6. So these numbers are the numbers coming from each individual matrices. And then from each matrix, I get the top left number. Okay. All right. And by the way, these numbers, as you see, are integers. Their data type is unsigned integer. So I think I had here what each from scikit-image, what each data type means. Unsigned integer 8 is corresponding to numbers, integers from 0 to 255. So what does that mean? When I come back to my matrix here, in this matrix, all the numbers are in between 0 and 255. So 255, what is 0 from 255? How many different numbers between 0 and 255, including these two numbers? There are 256 numbers. So if you were to represent 256 in binary format, how many bits do you need? So 256 is what? 2 to the power of 0, 1, 2, 3, 4. What is 256? If I say 2 to the power of 8, so what is equal to? 256, right? So there are 256 different numbers. Each number is represented in binary format with 8 bits. So that's why we have this 8 here, okay? So again, uint 8 means the numbers are between 0. If you represent each number with 16 bits, in that case, you have 2 to the power of 16 different numbers. If you represent each number with 32 bits, then you have 2 to the power of 32 numbers. So this is what these that's what it means, these numbers. Now, this u means it's unsigned. In other words, these numbers are only positive. There is no negative number. If you just say integer 8 without u, that means numbers are, again, there are 256 numbers, but then numbers are not changing from 0 to 256, but they are changing from negative 128 to 127. Okay, let's get back to our images. Okay, so now I have some understanding of 3 channels, 3 matrices, and then I can print the numbers from each matrix corresponding to the same location in each matrix. So I know that. Now, and another thing I noticed is all these numbers as of now in my image are integers. So remember I said we can change the type of these numbers. So what if I want to represent these numbers as float numbers, as decimals? So it was easy, right? So we just learned. So what I'm going to do is I'm going to take my image. Okay, I'm going to take my image. I'm going to say as type float. That's it. But remember, I told you at the time, if you do this, then your numbers are going to be turned into float numbers, but your image will not be scaled. In other words, the numbers are still between 0 and 255. So I'm going to do S type transformation on my image, as well as from SK image, I'm going to use this function called image as float. Okay. So when we first read this function, we may think that it is doing the same thing as image as type float does. S type is for numpy array. This image as float is actually a function coming with SK image. Okay. We may think that these two are doing the same thing. They're not doing the same thing. Okay. So let's see what is the impact. I'm going to take the same numbers. Remember 096. I'm gonna plot the same numbers. I'm gonna plot the numbers in the same location. So let's say this time image 2. Okay, so remember 096. Now I'm gonna plot this. So now it is 0, 0.035, 0.02. What happened here? Why might numbers suddenly change from 9 to this, 6 to this? So let's look at a little bit closer. So if I say this divided by, let's say, 256. So let's see what I'm gonna get. So remember, image 00, this corresponds to 096. I take these numbers, I divide it by them 256. Look, 0.0351, 0.03, almost get the same result. Actually, if I divide this by 55, I may get the same result, actually. Yeah, I get the same result. So what happened here? What happens is this image as float, when it turns my integer values into decimals, it also scales my numbers. Scaling means it divides all my numbers in my image array by 255. Why 255? 255 is the highest number you can expect in this array. So why 255, not 256? I know there are 256 numbers because one of the numbers is 0. Okay, my numbers are changing from, integer values are changing from 0 to 255. There are 256 numbers, but the maximum number is 255. Image as floats turns my integers into float numbers by dividing each and every number by 255. Okay, how about as type? Okay, what does as type do? So let's see, image 2, image 3. Okay, remember, image 3 is as type. So I still have the same numbers, but this time I have these decimal dots next to them. That means my numbers are not integers anymore. They are just simply decimal numbers. That's all. Okay. All right. So here, yeah, I tried to, here there are, I gave you 3 examples. You can run yourself and then see. I just tried to demonstrate what I tried to explain here. So what is the difference between S-type and then simply turning an array by dividing by 255 and then using image as flow. So what is the difference? You see 255 is turned into 1. So we basically scale the numbers. All right, let's continue. I think we spent too much time on this. So let's go back to our image one more time. So this is our image. Now let's slice our image in a different way. Let's slice our image in a different way. So far, this is what we did. This is the only thing we did actually in terms of slicing from our image. It's actually, this part is not directly related to images, but it's related to how we can manipulate data using NumPy, right? So again, remember this was our image, and this was what we were doing, 0, 0, and then that's it. So when I run this, it gives me the values from each matrix corresponding to this specific location at each matrix. Now what I want to do is, from the first, there are 3 channels. From the first channel, the first matrix, there are 3 matrices representing this image. I want to get the first 10 rows, the first 10 columns from the very first what is the matrix? Remember, there are 3 matrices, right? 3 channels. I want to focus on the first matrix, which is corresponding to red color, which is giving me the intensity of the red color. Okay. And then from the first matrix, I want to get the first 10 rows, first 10 columns. So first of all, these what is it? Commas are used for separating dimensions, right? So this is the first dimension, this is the second dimension, this is the third dimension. The third dimension is corresponding to those matrices. If you set third dimension to 0, you talk about the first matrix, which is red color. The second, green color, the third, blue color. Okay, so I want to focus on the first matrix. That's why I set it to 0. Okay, that is the first matrix. Once I set this to 0, I'm sure that I'm in the first matrix. Now I can play around with the first matrix by selecting certain numbers of rows and columns. So that's what I'm doing here. So the first 10 rows, so once I set this to the first matrix, on that first matrix, this is the first 10 rows, and this is the first 10 columns. So, and here are the numbers, first 10 rows. And these are corresponding to intensity of the red color. Okay. Okay, perfect. So I'm just skipping all these. These are probably when I was trying to uh, explain, I probably typed these things, so I'm just skipping them. All right, now we read the image. We're gonna come back to this image, okay? So we read the image by imread. Now I'm gonna save the image, okay? I'm gonna save the image. Did I make any save image here? Okay. So what I'm gonna say, this is my image. This is my image that I read. As of now, IMG is a numpy array. Now I'm gonna save this array as an image into this folder with this name. Okay. All right, let's save it. All right. We're done with, for now, we're done with SK image. We're gonna come back to SK image. Now I'm gonna getting into the next library, which is extremely important library when you are dealing with images, OpenCV. Okay, so let's now talk about OpenCV. And by the way, I didn't check if you guys have any questions. This may be too slow for some of you. Some of the things will be very basic. You already know. Again, my assumption is we know really we are very beginners. Okay, very early beginners to this topic. So that's my assumption. All right, so let's look at OpenCV now. So with OpenCV, we can do so many amazing things. Again, hopefully, if you can join me maybe in the third workshop. So we're gonna do so many different things with OpenCV. Right. For now, we are just going to read the image and do some very basic operations. Okay. So OpenCV is a little bit interesting when you want to install. So this is how you install. And this is the name of the library, OpenCV dash Python. All right. So we are going to use matplotlib. We're going to use NumPy. We already have them. And we're going to use OpenCV. Okay. If you guys are ready with OpenCV, let's continue. Right. So when you import OpenCV, when we import NumPy, we say NumPy, right? But interestingly, when you install OpenCV, you install saying OpenCV-Python, but when you import it, you say CV2. Okay. So import CV2 is corresponding to OpenCV. All right. Don't be confused. Okay. I'm importing CV2. I'm importing NumPy as MP. This time I'm importing matplotlib pyplots. So from matplotlib, I'm importing pyplot, and this whole thing is I'm using the alias or abbreviation as alias, okay, as PLT. Okay, so I have three libraries. Now I'm gonna read the same image, RGBY. Okay, again, luckily we have the same function. This time imread is a function of CV2, is a method of CV2. Earlier imread was a method of SK image, but luckily we have the same names. Okay, it may not be the same. So this is the path to my image. This is the image. Now there is one thing here. There is one thing here. Actually, there are two things here. Okay. The first thing is now I have an additional parameter. Earlier, I was simply reading the image. Sorry for scrolling up. I hate doing this, but here, right? So when I imread with SK image IO, this was the only thing I used. I just read the image. So this time I'm doing a different thing. I'm not only reading the image, but when I read the image, I say something additional. So what is this parameter? This parameter tells whether I want to read the image as a gray image or as a, what is it, a colored image. Okay. So first of all, let's see what is the difference between these two. Okay. I'm gonna actually take this guys out so that we can focus on this. Okay, so now I read the image in two ways. One is using this parameter, setting this parameter value to 0. The other is setting the parameter value to 1. So I'm just curious, what is the gray? First of all, is this whatever I read and assigned to gray image, is this a NumPy array or something different? Okay, let's just first check this one. Type. Is it still NumPy array? Yeah, it's still NumPy array. That's good. So what I read as an image is assigned to a NumPy array. So at least I know my way around with NumPy array, right? Okay. Second thing is, what is the shape of this? Right? Well, I read the same image. Remember this image when I read it, it had 3 dimensions, and the third one was corresponding to channels, and that means the image was colored image. This time, as you see, the shape of my image is 2-dimensional because I specifically said when you read this image, you know what, read it as a gray image. Okay. Okay. How about this IMG, which is reading image as a color image? So this one You see, it has 3 dimensions. The third one has 3 channels. It says there are 3 channels in this image. Now I'm reading my image in 3 colors. That was the first thing I wanted to bring to your attention. The second thing is very important. And Chuba, I already shared the notebook. I just saw your message. It is here. Okay, this GitHub account. So let me share this one more time. Oh, my friends already shared. Thank you. Okay, let's go back here. This is the first thing. Second thing is very important, and then most of the time when you deal with images using CV2, we may get confused. So when you deal with colored images, this is what we keep hearing. Okay, so colored images has 3 channels. Yeah, we already learned about that. And those channels are RGB. Okay, what is RGB? R is red, G is green, B is blue. Okay, so that means if you have 3 channels, the first channel is red. In other words, here, if I take this image, okay, and then take the top left numbers from all the channels, okay, from all the channels. That means in this case, if you assume this is a red, green, blue RGB image, 38 corresponds to red, 3 corresponds to green, 0 corresponds to blue. But that's not the case with CV2. When CV2 reads the image, rather than reading it as a red, green, blue, interestingly, it reads the images as blue, and then green, maybe it says green, and red, BGR. Why? I don't know. I wish it was RGB, okay? But this is important, okay? This is important that you know when you read images with CV2, the color images are encoded this way, okay? So that means 38 is corresponding to blue, 3 is corresponding to green, 0 is corresponding to red, okay? Not the way around, all right? Okay, now here I am printing, I read my image, okay? My image has this many rows, this many columns with 3 channels. This is the top left, the same thing. This is actually from all 3 channels, the zeros in the first row, and then the 400th, what is it, column. In other words, it is top right. It is top of the image, very right, okay? And this is bottom left, because why am I saying top right? Because my image has these dimensions. Imagine that this is a frame, okay? The height of the frame is 586. The width of the frame is 415. So if you go to the 400th column on that frame, you're basically towards the very end of the frame, right? Towards the right. So that's why 0400 means we are talking about the top of the frame and very, very far right of that frame at the top, okay? Now this is bottom of the frame, but very left. And this is bottom of the frame, but very right. So we got top left, top right, bottom left, and bottom right numbers. So these are the pixels. And each pixel is represented by 3 channels. Each channel corresponds to one of these colors, red, green, and blue. And these are the intensities of those colors. But this time I know that the order of the colors is not RGB, but it is BGR. Okay, that's what I know. Okay, so what is the implication of that? Now, remember I used ImShow. Now, ImShow is working based on RGB. So it treats the first number as red, the second number as green, the third number as blue. That's how it understands. But CV2, when it reads the images, it actually encodes them in the different order. So when I take this image that I read with CV2, and then and by the way, this image was closed it, or this one. This was the image. Remember, this is our original image. This is what the image that I read. Remember, this part is blue, this part is red, okay? But when I show this image, which I read with CV2, normally this part was supposed to be blue, right? This part was supposed to be blue. It says red. Okay. Now, but basically the colors are messed up, right? So because the order image CV2 is assigning values to colors is different than how ImShow is interpreting those values, right? So that's why I said it's important that we know that the images, when we read them, are actually encoded in a different order. But what are we gonna do now? Are we just going to let it go? No, right? So we are going to say, I know that when I read my image with CV2, it is BGR. So CV2 is allowing us to actually turn it around. So there is this function actually called color BGR to RGB. So what I'm gonna do is I'm just going to turn my image back into RGB. But this image as of now, when I read with CV2 is BGR. I'm turning it into RGB. Now, when I print my image, you see, I receive the original image again. Okay, I think I hope that we got the point here. So there were two things I wanted to mention. One is you can read your image in grayscale in color mode. Second, when you read your color images with CV2, the way the color images are encoded, okay, the order of the matrices is different with CV2. Okay, let's continue this. Let's do some more slicing. It's very, very important when you deal with images. You are gonna do tons of images. It's so important. Okay, so we have to be very comfortable with taking a certain part of the image, okay, moving it around, filling that part with some other numbers, replacing them, filtering. So it's very important that we are very comfortable. So what I'm gonna do is, remember this was my image, and by the way, the time is almost up. Okay, time is almost up. So I'm going to stop in 5 minutes. All right, in 5 minutes. What I'm gonna do is, remember this was my image. So I have 3 channels. I'm gonna slice my image into blue, green, red. Remember this is BGR. I'm gonna take the first matrix. It is the blue one. The second matrix, green, third. How can I take the first? We already learned about that, right? So let's remember one more time very quickly. Again, this is my image, which is a NumPy array. These squared matrices are actually going to contain my dimensions. I know that my image has 3 dimensions, so I'm gonna put these two, what is it, commas. So each comma is separating one dimension from another. So this is the first dimension, second, third. So if you want to pick the first matrix, which is corresponding to, in this case, blue color, so I'm gonna put 0 here. Okay, 0 means I'm choosing the first one. And then from the first one, from this first one, now imagine that you got this frame, the first one, the first matrix. Now you can say whichever rows and columns you want to pick from this very first one. Okay, so if you say this, that means I'm selecting all the rows from this first matrix. And if I do this, that means in addition to all the rows, I also select all the columns. In other words, I'm selecting this whole first matrix. Okay, this thing is the whole matrix 1, which corresponds to blue color. I do the same thing for green and red. Okay, perfect. But I know what it is now. All right. Second thing is, now I'm thinking that I sliced my image. I only took the reds. This is red only. I'm going to take this red, which, by the way, let's go step by step here. Okay, red. I'm just curious, what is the dimension of red? Okay, red shape. You see, red is a 2-dimensional matrix. I just picked the first matrix. Now, in my mind, because I got the first matrix, which corresponds to red, when I show this red in ImShow, I will see all the red color. That's what I'm expecting, okay? So before doing that, so by the way, this is red. I'm going to turn this into, so this is red. I'm going to turn it into RGB red, okay? And then I'm going to plot it and expecting that I will see red color. That's not what's not, this is not happening. All I see is, no, Here's some, I don't know, uh, black color and then white color. So why what happened here? I want to see how my first channel looks like. Red. Okay, I'm just printing red on here. It's a bunch of numbers between zero and some numbers are small numbers. Numbers on the right hand side are, let's say, I'm selecting the first 10 rows and the first, say, 20 columns, okay, from red. So these are small numbers. Now I'm gonna select from the same rows. I'm gonna select maybe what is it from 400 to 420, and I'm just going towards the end of the frame, okay, towards the right, okay. And these numbers are very big. Now I understand that the first half of the matrix are composed of small numbers. The second half is composed of large numbers. So that's why when I show my red matrix, half of it is different color, the other half is, and by the way, this color is just black and white. Okay. I know that now by default, these numbers are assigned to a color map where bigger numbers are white and smaller numbers are black. And I'm not seeing any red color. Okay, so that's confusing. Okay, I'm confused now. I want to see red color. Okay, so here's maybe I can do the same thing on the black on what is that blue color. I will observe the same thing with blue color or green color. Okay, so let's just put it there for now. Okay, we're going to come back to this. So another thing is, if you like, as I did in here, one by one, I split my image into 3 channels. Using CV2, you can actually split your image into 3 channels at once. This split is actually a function, a method of CV2. This is our original image. And remember, the order is BGR. So the first matrix is blue, the second matrix is green, the third matrix is red. Now, you can split them and you can merge them. Now, what I'm gonna do is I'm gonna split them. So let me run this. And by the way, yeah, this is another thing which I find it annoying, by the way. Uh, remember imshow? I used plt.imshow so far, right? What is imshow? I'm showing the image. I'm printing the image on the screen. CV2 also has its own imshow. This is not PLT, this is CV2. So what it means is when you run this, it's not going to be printed on this notebook, Jupyter notebook. The image is going to be on a separate window. And that window, the separate window, it's going to wait until this wait key 0 means that window will be remaining open until you push another button. Then the window is going to close. Okay. So that's what I'm going to do. First, I'm going to print the image. I'm going to print the image, green image, one of the what is it, matrices, and then I will merge blue, green, and red, and then I will print the merged image one more time. So and then let's see what happens. Okay. By the way, I'm going to drag this here because it's printed on the other screen. You can see, right? You can see my screen. So this is the green picture. This one. You see, it is still here. I'm not seeing the merged picture yet. When I click escape here, I see the second image. It's here. So they are both now printed on the screen. So this one's the merged picture. And then I'm going to destroy all these windows by hitting another escape button. They are gone. Okay. So again, you can search for this destroy all windows. It's something that I experienced some difficulty with, so that's why I put these two. So this without this very last line, destroy all windows may not work. In my case, it's not just closing; it's just getting into an infinite loop. Okay. All right. So I think I'm beyond the time limit now. So let me stop here. This took longer than I expected. Let me stop here. Maybe I was too slow. So next time we can move a little bit faster. So please join in our next workshop on Sunday, the same time. I live in California. It's gonna be 11 PST, right? We are going to first finish this workshop. I'm going to post another file, and then we'll do our best to finish the second file. And then we're going to have the third one. My goal is at least we're going to have some good idea about, at least can we implement some filters on the images, so that say, what does Gaussian filter mean? Okay, what is it doing on the image? So my goal is finish up to that part. Okay, so thank you for listening to me. So there was question. Yeah, I taught around 1998. No, I didn't teach at SJSU at 1998. Thomas, I wasn't there. Yeah. Okay. Thank you for listening. I already shared this. I didn't add anything. So the file that you have has all the code that we used in the class. Okay. I'm expecting to see you guys in our next meeting. Until then, take care of yourselves. See you guys. Bye.